Hi folks, in the last part of this lesson we're going to look at one application where we often see radians, and it's is this idea of angular velocity. So this is something that you might have seen in physics. Okay, so what angular velocity measures is how quickly something is turning. Okay, so let's say we take the example of something moving around a circle. Okay, so rotational motion. Okay, so moving around a circle, and we might want to describe how it's turning around this circle. Now, one way would be to use, traditional idea of speed is the distance traveled per unit time. Okay, so let's say the object is moving at 1 centimeter per second. Okay, so while this tells us, how quickly it's moving with respect to distance over time, it's not necessarily the best way to describe how fast it's turning, how fast the rotation is. And think of this, if you've got a, say, smaller circle, okay, and you say that the object is moving at 1 centimeter per second, well here 1 centimeter per second, there's 1 second, there's 2 seconds, there's 3 seconds, there's 4 seconds, okay? So it takes about 4 and maybe a third seconds to go around the circle. Whereas here, if this is moving at 1 centimeter per second, 1, 2, 3, 4, and a third, we see that it doesn't even make it halfway around the circle. So when we're trying to describe how quickly something is turning, the actual turning motion using traditional speed isn't too useful. Okay, so we define this idea of angular velocity, which instead of measuring distance with respect to time, we're measuring an angle with respect to time. And usually that's measured in radians per some unit time. In this case here, the question we're going to look at is asking us to describe the motion in radians per second. Okay, so what's the rate of change of the angle as you're moving around? Okay, so if you're moving around the circle at the same angular velocity, that would not change with respect to the size of the circle. Okay, so let's take a look at this example here. It says if a wheel makes 75 revolutions per minute, determine its angular velocity. So here what they're doing is they're giving us a sense of motion with respect to time, but here they're describing the motion with respect to the number of revolutions. Okay, whereas here we want to describe that motion with respect to the angle at which it moves, so in radians, and in this case here per second. So if we take 75 revolutions per minute, okay, and certainly those, chemistry and physics students will be doing this thing all the time, changing units. Okay, so let's do this step by step. If I'm making 75 revolutions, well, we determine that one revolution corresponds to 2 pi radians. So 75 times 2 pi radians, okay, per minute. All right. Now, as you're doing these changes of units, one thing to keep in mind, just to kind of check your answer along the way, is think, well, if there's 2 pi radians in each revolution, then this new number should be a larger number. So it makes sense that I'm multiplying by something bigger than 1. Okay? But I also want this given in terms of seconds and not minutes. So here, all you have to do is say, well, instead of working in minutes, I'm just going to replace minutes by the number of seconds that it represents, which is 60 seconds. Now again, let's see if this makes sense. Okay, you got to figure that the angle that it traverses in 1 minute is going to be much bigger than what it traverses in 1 second. So it makes sense that this number should be smaller. It's smaller because instead of dividing by 1, I'm dividing by 60. Okay, and so now we can do this here. So what do we have? We have 150 divided by 60. So that is 60 goes in twice, 120 plus another 30. So this is 2.5 pi radians per second. Okay, so this is the angle that the object is traveling in 1 second. And of course, since this is a problem with a context, well, we can also look for an approximated answer. It looks like I checked it before. 2.5 times pi. Yeah, 7.85. So that's about 7.85 radians per second. Okay. Now, in this case here, it might be a little better to work with 7.85. It gives us a sense of how many radians. Okay. Now, remember, it took 6.28 radians to go around the circle. Okay, so this is a little more than that. So you're going a little more than a full turn around the circle. Okay, maybe an extra sixth around. Okay, that's it for this one.